Hey friends, welcome back to the channel, and in this video let's talk about Bloom filters. Now, what are Bloom filters? They are kind of a special kind of data structures, and these are like probabilistic data structures. And the key property associated with Bloom filters is that they tells with 100% certainty that an element does not belong to a set. Now, if the Bloom filters say no, we can definitely say that it is not there in the set, which is 100% accurate. But if the Bloom filter says yes, that means that element might be in the set, which is false positive. Now, the use case for that is consider Instagram Reels. So, the Instagram Reels, you have tons of reels on the Instagram servers, and the problem with that is uh, don't show users the reels that they have already watched. Now, in this case, Bloom filters come into existence that if it says no, that means the user hasn't seen that particular reel, so you can show it to the user. Now, the trade-off for that is the speed versus accuracy. So using Bloom filters, you will get speed, uh, but it won't be that much accurate because you have allowed false positives. Now, the naive approach could be we can simply use a set to just check if the user has seen that particular reel or not. But but what is going to happen is that for each reel, we are going to iterate a set. If they have already watched it, we are going to discard it. If not, we are going to recommend it. But this is a very naive and a very bad approach because users watch hundreds and thousands of reels daily, and in a database we have tons and tons of reels with us. And as the set grows huge over time, we have like millions of entries per user. We cannot load it into a memory to check the existence of that particular reel for that particular user if they have seen it or not. And set is using a binary search tree, which is a log of n lookup, and it has a massive memory footprint. And if you talk about millions of users and then they are watching thousands of reels a day, which is a very, very unsustainable approach if you're talking about memory only. So the key insights here is once the reel is watched, the reel is not recommended to that particular user, and we don't need a remove operation. So how can we optimize it? So for that, we simply have a Bloom filter. Let's understand how it works. So for that Bloom filter, we need a bit array and a hash function. So for example, we are using a 8-bit Bloom filter. We have a bit indices with us, and initially we have set all the bits as a 0. Now, we are inserting a string, let's say apple, and we have a hash function associated with it. Now we got a bit, and we are going to set that particular bit as 1. So here we have set the second bit as 1. Now we are inserting ball. Again, we have a hash function, we have bit 6, we have set that bit as 1. Now, third, we have cat, and for that we have again bit 2 that we need to set, which is already set, so we need not to make any change. Now let's consider this particular string, which is dog, and the hash function will give us number 5 and will check that if the bit 5 is set or not. In our case, it is not set from the beginning to the end, and we can definitely say that dog is definitely not in the set. Whereas on the other hand, for the elephant, we'll see that the hash function will return a 6, and we'll check in our bit array that 6 is already set. Now, in this case, we are not sure. Elephant might be in the set, might not be in the set. This is kind of false positive that we'll have. Now, in this case, we have like saved a lot of space. So talking about all these three strings, we have 12 bytes, but we have stored that data in 8 bits, which is just a 1 byte. And talking about hash functions, we can use any deterministic hash, be it MD5, SHA, etc. Now, talking about false positivity rate and how we can scale. So as of now, we just talked about an 8-bit array, but if we are talking about millions of users and thousands of reals, how we are going to scale it, and we need to keep this false positivity rate as low as possible, because if, let's say, we have a very small bit array and all of its bits are set to 1, every query is going to return yes, and this is like 100% false positive. So for that, we have a formula which is quite simplified. You can obviously have a Google search about different kind of formulation for this, and in this case we have something like this formula with us, where m is the Bloom filter size, n is the expected number of elements, and p is the desired false positivity rate. So for example, if we have 1 million elements with 1% false positivity rates, we'll be having the size of Bloom filters to be like 9.6 millions or 1.2 MB, which is very, very low. And to one thing to keep in mind, that whenever we create a Bloom filter, its size is fixed at the time of creation. It is not dynamically updated. We cannot grow it as our user base increase. Now, what we can do when our user base increase, or we need a bigger Bloom filter with us, it is going to be simple. We need to create a new larger Bloom filter, and we need to insert all the keys from the source DB to our new Bloom filter. Now, the trade-off that we have is larger filter we have lower false positive rate, but will need more memory. Now, talking about the real world use case, so recommendation engines uses it, like Instagram, YouTube, Medium. Now these are simply, as we had discussed before, to keep track of the content a particular user has watched or seen. We are going to only recommend content that user has definitely not seen, especially in the case of Instagram Reels or YouTube Shorts. And talking about, we can have web crawlers. So if we have to track several URLs, we can simply have a Bloom filter. So if the Bloom filter says no, we have to crawl that URL because it is definitely new in our user base. And if the Bloom filter says yes, so we might have crawled it before. Third, like feed generation, like Twitter, Facebook, LinkedIn, talking about dating apps, spam detection, and database query optimization. All of these things where false positives are acceptable, but false negatives are not, we can use Bloom filters. We don't need that much extra space like set and all. So these are the real world use cases. So this was the whole discussion about Bloom filters. We'll be having a bit array and a hash function. What are the key properties of Bloom filters? What are the trade-offs that we need to make, and when we need to use Bloom filters? And in the HLD interviews, we can obviously use it for some kind of recommendation engines, web crawlers, all of these things. We can have a brief discussion on the trade-offs between space, speed, accuracy, and we can also talk about the native support in Redis and all. So that was the whole discussion about Bloom filters. What are they? And I hope you find this video informative, interesting. And that's it for today's video. See you in the next one.